What's up, everybody? Welcome to System Crafters. I'm David Wilson, and we're back again with another Spring Lisp Game Jam 2024 stream, where we're trying to build a kind of like a dungeon defense game from scratch using Guile Hoot, which is a Scheme 2 WebAssembly compiler that is developed by the Sprightly Institute. So, yes, number one, sorry I'm late. I had to help clean up the kitchen a little bit before we started the stream. Number two, Twitch stream is not working today because Restream, once again, has decided that it doesn't like the frames that my OBS instance is sending to it. So for some reason, it just decided to not start the YouTube stream, and the Twitch stream started probably for 4 seconds and quit. I think I need to find another alternative to Restream for streaming across the streaming services. It's nice to be able to stream to Twitch because, at least for the Game Jam, there's been quite a number of people coming to see it. So it's unfortunate to have to miss those folks, but that's what we have to deal with today. So in the last stream, we managed to get a basic editor created using Hoot. And if you want to see what that looks like, it's right here. This is the current state of the game. We still have these sort of randomly walking around monsters and hero character. Nothing new there just yet. Well, there is one thing that's new, that we have a different type of monster. So there's now 2 types of monsters. We could have as many as we want if we decide to. We also have randomly generated monster names, which are completely nonsense. Just the simplest possible way to generate names at this point. But we might improve that later. Really, it's not a big issue at the moment. Also, we have the basic script editor here. I mean, this is just a text area, so it's not really anything special, but and we will be able to get into, writing some logic scripts in here. And that's sort of the idea today, is today we will take this editor functionality, we'll be able to select one of the monsters and then edit their script and then be able to save and run it. So whenever you select one of the monsters, you would click run. It looks like it's actually saving it when I switch, which is not what I expected, but maybe that's not so bad, I don't know. But we'll have to take a look at that. The idea, though, is that we will implement a basic scripting language that is Scheme-derived, in a sense. It's not real Scheme code. It's going to be completely interpreted by the game code that I write. And the purpose of it is to make it possible to write simple logic for the monsters to do certain things. So you can basically assign different jobs to the different monsters to prevent the quote-unquote hero from stealing all the treasure or causing other harm to the dungeon. Let's see. Let me get this stuff out of here. I actually fixed the auto publishing of the game today. So I finally got the Woodpecker CI automation set up correctly. So if you go to fluxharmonic.itch.io/lambda-dungeon, you can actually go play the game yourself. You can click run game and it's going to pop up a full screen view. Whoa, what was that? It didn't do that last time. Let me refresh the page. Run game. There we go. So it takes a moment to load up, but eventually it will load up and you'll get the same thing that I see in my build of the game. So that now we have 2 instances of the game running in the browser at the same time. So every time I push commit to the master branch of the game project, a new build will be kicked out to this page, so you'll get to follow along as we make progress, and hopefully that will, give you a chance to try it out. You should keep in mind, though, that you need to have a relatively new version of Chromium or Firefox to run the game. It doesn't work in Safari at all. Also, I would recommend not running it on mobile browsers. It probably will work on some mobile browsers, but the game is not really set up for, mobile screen size or interaction styles. So you'll want to have a desktop Chromium 119 Plus or Firefox 121 Plus browser to run the game. But you should be able to run it just fine if you have those. All right. Hello to Peter and Alejandro in the IRC chat. I haven't seen any messages on the YouTube side yet, so if you're here, say hello in YouTube. So that's the state of things at the moment. I guess I could tell you what the problem was in the end for me to get the publishing working correctly. It's actually really stupid. Where is it? Yeah, I was using the wrong syntax for the publishing target. I was using fluxharmonic:/lambda dungeon/web. It should have been /lambda dungeon:web. it kept telling me wrong target or like invalid target. I'm like, what does that mean? And I went and tried like, re-log in, create a new token and all this kind of stuff. And then it just turned out that I had the syntax wrong. So that one's on me, but now it publishes just fine. And if you want to see the entire Woodpecker script that makes this possible, I basically just use my own Docker container to build a game because I already have Guile Hoot and Guile plugged into this container. I just run make to build a game, and then I use a separate Debian container to install Butler by downloading it from their site. And then I kind of prepare a distribution folder by copying files into the dist folder, and then I just publish that using Butler. I have my Butler API key set up as a secret, as an environment variable, so that automatically gets picked up by Butler whenever you try to publish. So the way that you get that is you download Butler to your local machine, use Butler login. It will send you to the itch website to approve the login, and once you get that, then it creates a file on your file system that has the token in it, that you can use that token in your CI automation to publish your game. So actually not very hard to do this, which is nice because it means that you can do like me and you can have a CI system automatically publish your game on every commit, so you don't have to go do that manually. Hello to Kaiser in the IRC. All right, so let's get started on the execution of the... Let's see, do I actually have that file open somewhere? No, I think I killed it. Okay, cool. So we'll get started with the script engine. And I haven't really thought too much about where to put the code yet, but we'll get that going. First, maybe I can just show you the notes, what we wrote yesterday. This is kind of the syntax I have in mind for this. It's basically like a match expression or a cond expression. Yeah, like a cond expression in a sense, but it's a bit more targeted. These are special purpose procedures, effectively, that are purpose built for the logic system. So you would have like a vocabulary of predicates that will do something. Like, for instance, these are a series of logic expressions that get executed in order. If a yellow key is present in the environment, then you would run like the take item action, let's say, and it would cause the monster to gradually walk over to where the yellow key is and try to take it. Then after that, it would try to find the open door and then lock the door. So this would only happen if the yellow key had been picked up. However, this is kind of wrong for the context of this monster if someone else picks up the yellow key. So there's no way to really have logic per se. I guess you could say, we could potentially do like an and has item yellow key. There you go. So has item yellow key and find open door, lock the door. So that's sort of like that could be a compound logic, I guess, for the monster. I think that should be a good starting point for what we're trying to do here. The idea also is that the result of the predicate, if it returns some kind of result that's more than just true, it can be passed along to the next procedure. So you would want to lock the door that accepts the yellow key, so it would sort of pass that yellow key information over to the door. I think it could do something like that. We may also need to add an extra syntax, kind of like an arrow. Arrow sometimes gets used in Scheme for saying that you want to pass a value across to the target. So we'll take a look at that. We'll just try to implement things slowly and see where we get today. So back in the game code, we have our game.scm file, and in the update procedure, we have a loop that will loop over every entity in the sort of the current tick. And I'm defining a tick to be once every second. So once every second, the update procedure will get called so that the entity logic will all be updated, and the whole world gets updated at the same time, all the monsters plus the hero. We may change that in the future, but I kind of feel like it might be interesting to experiment with how you would have to be editing the code in real time to react to things that are happening in the world. So if you want one of your monsters to do a specific thing, you're gonna have to go to their script and edit it to change their behavior. I'm not sure how well that's going to go, but that's the point of doing game jams. It's just experiment with different ideas and see, what comes out of it. It may not be the most fun game in the world, but it'll be fun to make it. It might be fun to watch me make it. Who knows? All right. So in this update entity procedure, I think that's where we're going to execute the script code. So if I go back over to entity.scm, let's see. We've got the script attached to the entity. Draw entity, update entity. So currently, what I've been doing is, this is sort of like a baked in procedure right now. I'm sort of just picking a direction at random that is walkable. So it's kind of like a loop that will look for a walkable tile in any direction. And then if it finds one, it will move the entity there. And that's pretty much it. That's the way that you see this current behavior with where the entities are just sort of wandering around. All of them just sort of following the same behavior. We need to instead have them execute the current script, which first means that the script, when it gets set, we need to not really compile it, but we need to at least parse it to get a data structure we can use to interpret what the script contains. So let's see, we have set entity script. We have make entity. I think what we might need to do here is make sure that set entity script, we might need to have a special procedure for that wraps it so that we can store their logic separately. Yeah, we do need that public set entity script. What we need here is to change the set entity script to be underscore first, because we're sort of making that like a private version that's just as the setter for this record field. Now, make entity, probably want to put it right here. I don't know if I really need to do that, but actually, no, I don't need to do that. Let's just move it down a little bit. Okay, so set entity script, entity script. Let me know if there's any issues with the audio or like lagginess of video or anything. So the easiest way to do this would just be to call set entity script. We're just going to wrap the inner procedure entity script, but we also needed to, compile, or let's say parse the script and save the logic. So we're also going to need a logic field. I'm going to make that false at first. We also need to go to the record type and say logic, entity logic, set entity logic, because we need to be able to set that at runtime. So there we go. Now we have the ability to store the logic. To make this work, we're going to want to read the content of the script. So let me check on where read is defined in Hoot. Let's go over to the Hoot code base. If I look for read, bin compile, bin eval. That's probably stuff that's not available to me. I would guess, oh, I think I just saw it. Hoot read. Hoot read. There's a module called Hoot read. All right, so we have read and string to number. Cool, so there's like a whole basic scheme reader implementation here so that you can take a, is it like a port or a string? What is it? Read. Read directive, read expression, character. Where is like just the plain read defined? Define, read. How do I do word boundary? Space. Here it is. All right, cool. So read optional port. Probably need to create a string port if that's possible. I would imagine it is. So we can import this read procedure from Hoot read. So let's go ahead and do that. Okay, and then we also need to have a string port. So let's take a look in Hoot also for Open input string. So is that coming from just plain Guile? Maybe that's already there in the default environment. So maybe I can just try to use it. Let's go into entity, set entity script. There it is. And then I can set entity logic entity. I'll set that as the result of calling read on, probably need to do a let on that first. So let port open input string script. That should be enough to get us there. And then here we will call read on the port. And that should do it in theory. Probably we will want to take a look at that. So pk script, or let's say logic. How about that? Logic. In theory, this should print that out. So entity logic entity. And then we set the script on the entity. Perhaps I should set the script first in case there's an error, but I guess if there's an error, we got bigger problems, so. Okay, so that should give us the ability to set the entity script. Now what I want to do is, in this procedure, I'll say let entity. I will create the new entity as a result of this. You know, I could actually, instead of having a default, well, I need to have the script and the, like I need a default script. So let's just copy that. So we're in the let here. We're going to close out the binding, and then we're going to set entity script entity, and then we're going to use the default script. So we're also sort of appending a little helper string to this to make it more obvious that it's a script for this entity. And in fact, I'm going to drop this down a little bit. Okay, that's good for that. And then we can close out this whole let and procedure definition. Hello to lube or lobe, who knows. So now we have a new make entity, and we're going to call our set entity script helper so that it will do the parsing of the initial script for us. We probably want to go change that initial script value to have a logic. How did I write that in the org file? Okay, so else wander. I think that's kind of the idea. Is the default will just be that they can wander. I don't know if there's any other like beginning logic that we should try to set up for them. Can I do that? Yeah, I kind of want to make this easier to edit, so let's do it this way. I might need to trim that string at the beginning too. We'll deal with that next. Script or name. Okay, that's actually quite advantageous. Let's just do that. Okay, logic, else, wander. We'll take a look at that and see how well it works. And I think that is actually lined up correctly. Okay. So make entity, we got our default script. All that should be good. I think we can test this now and try it out. So let's go to compilation buffer and try to run that. How's the music level? Is it too loud or is it fine? Duplicate imports. I don't know why hoot-read is exporting string to number also. Can I import only? Let's see, Guile, use module, find module. Let's see, creating Guile modules, using Guile modules. I want to just pull out that one binding. I don't want to pull the other one because it's causing me troubles. Where is it? Okay, using Guile modules, interface specification, select. So I could probably just use select. Cool. So use modules, IC9P open. What about the other use module syntax? Is it the same thing? Let's try that. So I'm going to, on hoot read, I don't know if this is the right syntax, but we're going to find out really quick. Hoot read select read. Bad select declaration in subform. Is possible that it's not supported yet. Let me go into Guile. Use module. Okay. Use modules. Trev says he's gonna read lips. Let me turn it down a little bit. I'm cool to turn it down. I mean, like, I can hear it a lot myself, so maybe it's too distracting for everyone. All right, that's a little bit lower now. Okay, I'm moving windows on the wrong screens. All right, here we go. Okay, use modules. Is there an example of select being used in here? Yes. But nothing in the hoot. Oh, right here, hoot backend. Surfy 1. Maybe I need to have this here. Still may not be right. Let's try it. Compilation. Still the same. Oh, wait, that's different. I think this is right. PK. So in entity, I also need to pull in use module. Boot debug, and that should get us going. No problem, Trev. Wrong number of arguments to read. Really? Not based on what I see, but maybe I'm using an older version of the code somehow. Read optional port. Oh, did I do something wrong there? 76. Read port. Oh, it's not a keyword parameter. No wonder. All right, I think we're good this time. Let's take a look at the output once it finishes compiling. I wonder if the compilation takes longer now that I pulled that library in. That would not be good. That took a while. Okay, let's reload the page. Any errors? Yes. Record with no printer. Wrong number of arguments. Okay, I know what's going on here. Make entity is not passing the correct number of arguments to, I guess this is not even doing it either, logic. Every time we add a new field, we have to make sure to update all the locations where it might be referenced. So I think that was the one. Now let's see the compilation time again. Yeah, this is definitely, I would say, another 4 or 5 seconds longer than it used to be. So we'll just have to get comfortable here. Okay, so we do see that the logic is getting loaded up. This is the actual list that I read. This is not the input script, so that's coming through. But now something else is happening. Entity name. Something, oh, logic. So what's happening there? That's kind of weird. This is after all the logic is loaded up. So logic, we know now that that's okay. So this is at the time that we're creating the game, I'm pretty sure. We're calling make entity. make entity itself, the real public version of make entity does not take a new parameter, so that's fine. This procedure appears to be working up until the point that we're doing this. So entity name is being given something that's, oh, I know what happened. I know what happened. That's my mistake. Okay, so make entity, I changed it to intercept the new entity and set something on it, but I never returned that value. And I think that's what's happening here. So after we set the entity script, we need to go and return entity. Almost type return, you saw me. I don't know what language I think I'm writing right now. Come on. Now I know what Dave was talking about. Okay, cool. So we do have logic here. Now it makes me wonder, what happens if I put the wrong number of parentheses? Cool. So we get an error. How can I intercept that error? Unexpected end of input while searching for A. I don't know what the A is in this case. So do I have the ability to catch errors? It's going to be necessary, and it will be nice to show an error message whenever the code does not parse correctly. It's an uncaught error, so it does appear to be catchable. So Guile catch error. I haven't really used exception catching before in Guile, but that's the first time for everything. Display error. How to handle continuation barriers. Is that what the thing is about? Signaling errors, how to handle errors, continuation barriers. Let's see, with barrier, what about handling them? Catch, wait. Transition from its historical catch and throw error handling and signaling to new structured exception facility. See exceptions. Okay. Throw and catch. Wait, what was that, about 25 years? Okay. Okay. So catch, key, thunk. Okay, so we need to implement a thunk with exception handler. That seems like what you're supposed to do in Scheme. Interesting. All right, so we might need some extra hooks for having, well, we need a log anyway. We need a log control in the screen so that we can write out messages about what's happening with the characters, but also for things like this where, you know, we need to show an error to the user. So that's something we can also implement while doing this. Okay, so with exception handler is the new thing. I wonder if that is in Hoot. It must be, right? Yep. Well, actually, that's not Hoot code. Let me see. Hoot. Okay, with exception handler, guard, and all of that. Great. So lib hoot errors.scm. That seems to be the ticket. Let's go to entity. We'll go load up. Set script. And then here we need to say with exception handler. And then okay, so that's our handler. Then we need to have a thunk, which is a lambda that takes no parameters and does some logic. So in this case, we're going to call set entity logic. And since we've captured a closure, we can mess with the entity from inside of this thunk, which is fine. All right, so with exception handler, there's also the unwind T. With unwind T, catch sets up an escape continuation that will be invoked in an exceptional situation before the handler is called. Unwind key for type. I don't think we really need it, but we'll see. Maybe we do need it. Maybe I'll put the logic here as well inside of the thunk, so that we get the print out of that inside. Okay. Let's recompile. Let's see. Error imported name, duplicate imports, scheme base. So scheme base apparently is pulling in a lot of stuff. Let's take out hoot errors then. Maybe it's not needed. And maybe read, this wasn't needed either. I don't know. Let's see. It does make sense that read would be part of base. Still unbound top level, whatever. Okay. So this time we'll go and reload the game. And I'll take off a print at the end, run it. Still throwing the error out. Non-continuable. Handled non-continuable exception. All right, is that the reason why we need unwind? That would make sense. I don't know what unwind for type does. So scheme with exception handler. Maybe we'll say for Guile. Oh, okay, here it is. With exception handler. Establish handler. If raise exception, all right. Exception handlers are non-unwinding unless it was invoked with unwind T. Exception handlers are invoked with a continuation of the error without unwinding the stack. Okay, yeah, that does make sense. That does make sense. Okay, so let's say unwind true. This is really the first time I've used exceptions in Scheme. Exception handler. We'll drop to the bottom here, right around this point, and say unwind true. Do you need that key? Yeah, maybe not. Let's try that instead. Lube says, can you describe how you're using Geeks in this setup? I'm just using it to run a manifest file. So this Geeks manifest file has just the references to the packages that are needed to build this project, which are Guile Next, Guile Hoot, Make, and Zip. And then I'm just running the make file in the context of a Geeks shell environment that is created as a result of loading that manifest. So the make file does most of the building work, but the Geeks shell command will set up the environment that's necessary to build the game. Okay, so let's try this one more time. Run. Excellent. So we got a struct here, probably an error. So I should be able to inspect that. And let's see, what was it? Errors.sem. Define record type? No. Error. Whoops. Error message. Is there like an error message? Error message. Error message. Error message. REPL. Error message. Let's see how this does it. Key. Interesting. This comes from the REPL. Exception kind, exception args. What do we see? Well, I guess we probably don't have that output from before. Enter WASM debugger. Ooh. And where's that coming from? So raise exception. What's it do? That looks like it must be calling some native stuff. Make runtime error with message. Make runtime error with message. All right, so plus irritants. Okay. Make runtime error with. This must be getting defined somewhere else. Here it is. Make export. Standard library. Make runtime error with message. So we got some literal WASM code being written. Struct new string int and a local. All right, so this is a struct of some sort. We also need to say exception kind. Interesting that this doesn't show up as being defined somewhere. Where is this? Exception type, exception kind. What does this say? What section is this in? Things that aren't implemented yet or are implemented? Oh, I think it said not implemented. Not implemented, not supported. Exception, all the exception related message stuff. And it doesn't seem to be printable. It's a struct, but I think that's actually a WASM struct at this point. That's not really helpful. How do I define? Interesting. Let's see. What do I want to see here? I want to look at the Hoot page. 041. What does it say about errors here? Non-continuable exceptions now include a message explaining what the error means. So that's the only things for errors. In the implementation of with exception handler, unwind. Okay, this is inline WASM. Is that it? There's some test code. Phrase continuable. Oh, hold on a second. I see. You can return values through the handler. So whenever you call with exception handler, It seems that the location at which you call it can return the exception or some other value that comes out of it. Lambda message irritants. Where does that come from? Make exception with message. Test call. Hoot exceptions. Yeah, I don't think this is actually available to the Hoot runtime. Could be wrong. I mean, there's errors here. Error handling. Maybe I'm wrong about that. Exceptions. Where am I? Hoot exceptions. Exception message. All right, let's take a look at that. Maybe that's where it is. Define exception type. Must be a syntax somewhere. Here it is. It's defining a record type. Let's see. Back in entity, we'll pull in use module boot exceptions. Just by pulling that in, we should be able to tell whether it's there or not. I'm not seeing any complaints so far, so it must be a valid library. So set script. Right here, we will say exception, come on, message. And we'll also change this to exn because that seems to be the exception variable name that is used commonly. And now we should be able to reload it and test out that the message comes through. And then once we have that, we will be able to send the message along to the log for the game. Let's run this. Unexpected end of input while searching for colon or tilde-a. Well, you know, that's not so bad. I mean, it's better than nothing. What if I do that? Is it going to be the same type of issue? Else wander. That's not valid. Unless it just stops as soon as it sees a valid input. You just have extra parens and it's okay. Okay, so we've got the object. We can deal with propagating the error message a little bit later. Let's start getting the interpretation working because that's the more important thing for the stream. So now in update entity, we need to decide how we're going to interpret the logic. So okay, so now that we have logic, if logic, there's a, so we need to do two things. First, we need to loop through all predicates and interpret them. If any predicate returns a non-false value, call the subsequent action list, I guess you could say. And that's pretty much it. And I want to move this. So let's move this into a procedure called wander. Oops. Entity. Is that enough? Entity. We also need the information about the level. So level, maybe the time as well. It wouldn't hurt to have the time just in case any actions are sort of time bound, let's say. And we're not really doing anything to store state for actions yet. I mean, it could be a thing in the future where we need to store state or like things like inventory, let's say. That's okay. We'll wait on that until later. So now that we have our logic here, we can loop through the clauses. And what we're going to do is skip the first. So if we look at the script here, we have logic here. We were just using that. I don't know, like we could call it anything we want. Right now, we're just going to call it logic. But for now, I'm going to just skip whatever that is. So let clauses. That would be the effectively the cdr of logic. And this needs to be a loop. Whoa, I turn on insert mode. And now we're going to run through each. So when pair clauses, then we're going to do something with a clause. So when pair clauses, first of all, we need to interpret what the clause is. We need a, let's see. Let's do that. So when pair clauses, we will say interpret clause, car clauses. We also need to, I wish Control A would just go to the beginning of the line. We also need to say if interpret clauses, clause. We want to stop at this point. Actually, we probably need to store the value of interpreting the clause. So first of all, how to do that? Let's say interpret clause. If result, let me think. Then we need to take the action of the clause. So in the, actually this needs to be car of car maybe. So when we take the first item, the first thing in the sub list is going to be the clause, and anything that comes after is going to be the consequent actions. So I think this needs to be CAAR to get the first item. Is that right? No, that's not right. It's not right. Okay, let's do that. Here we go. So if result, we're going to execute. So there are clauses, let's say, and we'll pass along the result as well. And then, otherwise, we're going to say loop. That's not right. Yeah, this is a problem. We need to say car of clauses and cdr of car of clauses. I think that's the deal here, because we need to say cdr clauses here to move to the next item in the clauses list. And we will put some print logs here to make it obvious what's happening. So if logic, let's just say when logic, because we don't need to be too prescriptive here. And we'll indent all this. We go to the end of the line and close it all out. Okay, so now we're not really interpreting anything. We're just, we've just implemented the loop, let's say, for interpreting it. So I want to print out each clause, PK clause. And this is going to be a car of clauses. I probably should be a little bit more careful also about the structure of this. I need to make sure that the author of the script is making it well formed. So we'll have to take a look at that in a minute. But it's not super important at the moment. All right, so interpret actions. Sure, I didn't actually implement that yet. So define, interpret, actions. No, not clause. Entity level clause result, let's say. And we'll also say false here because we don't care. So we need to pass along the, what was it? Entity level actions. Okay, I forgot the actions part. Here we go. Now we'll compile that. Wrong number of arguments to interpret clause. Oh yeah, that's right. Interpret clause wants a clause, an entity, and a level. Yeah, we need to fix the ordering here. So for clause, we're going to pass entity and level. Fine. There we go. Okay, now we will, see? So we're seeing a bunch of clauses being iterated over. So we have an else wander here that keeps getting printed out. So I think that's indicative of, it does not appear to be finishing. It's an infinite loop because I don't see the entities moving. So it must be an infinite loop. Wonder how bad that's chewing the CPU right now. Proced. Oh, OBS is still the one taking out the most. That's fine. How did I do this wrong? Interpret actions. I said false. So if result, that should be false. Interpret actions. Otherwise, loop clear clauses. When pair clauses, the cooter of clauses should have gotten us out of it. Can I say who the entity is that we're doing this for? Just to see, just to make sure that it's the same one. Oh, we're not executing anymore. So actually, they're not moving because we're not executing wander at this point. That makes sense. Okay. Yeah, okay, that's fine. It's doing what we expect it to. So now we've got the clause being executed, or at least it's trying to. We need to implement an interpret clause. We could try to do a match here, I think. Match clause. And we can say else here. Else. Is that right though? Would it be that? And then what is the way to do an else in match? Let me go take a look at the match syntax. Guile match. Pattern matching. They have a little bit of a grammar here, I think. I just use true at the end. True, false, else. Okay, so probably just true. Oh, that wouldn't work, would it? Any? Anything, underscore. There we go. Come on. Okay, so we're at least saying that it's else. I'll say false for now, because we're not actually, well, no, let's say true. Come on. Okay, so now we can recompile. Hey, Dave. Yeah, I'm going with a much simpler approach than using a real metacircular interpreter. It's just going to be very simple. But it's good enough to sort of prove the point that you could have, you know, code being interpreted in the browser. All right, let's load it up. It's else. Okay, so we are actually matching the else here. I see it once. Oh, okay, it's printing out a bunch of times. That's the reason why we only see it once. Cool, so now that we know it's else, we can do the same thing for actions, I think. Actions would be pretty easy as well with match. Match. Ooh, we need to do a recursive loop on actions. I mean, the idea is that you would support multiple yeah, we could support multiple actions, but maybe let's assume for now that we don't. Because I don't really know what it means to do multiple actions in the context of what we're supporting here. But for now, here's what we'll do. Wander. So if this is wander, I think we need to use a single quote here to indicate that this is a list with a symbol in it. And here we'll say pk unknown action. And the return value doesn't matter too much, but we're going to return one anyway. Actually, maybe it doesn't matter at all. Let's just leave it be. So interpret actions, we've got that already. Hopefully we'll see the entities wandering around. Oh, wrong number of arguments to wander. Cool. Wander needs basically the same type of information. So entity level DT, we'll take the DT out because currently it's not being used. DT, all right. So then back to the action. Whoa, what did I just do? Yeah, okay. Interpret actions, there we go. So wander needs to have entity and level. Taking a while. Here we go. Unknown action, it says. So the match expression is not working. Oh, you know why? Because I didn't take the car of actions. I'm still assuming that it's going to be a single item, but it's actually a list of lists. Compile time really increased whenever I included hoot read. Still saying unknown action. Let me print out what I'm getting for actions in this case. So pk actions, actions. because we need to see what the structure of the information is. I could be getting something completely wrong. It could be an empty list based on the way that I'm doing this. It's a list with a wander expression. Okay, maybe the match syntax is not what I think it is for this. Maybe it's more like, let's see, pattern of in elements or more, a symbol, list of in elements. Are those for bindings? Can I use a... Yeah, okay, let's do that. I think that must be what the problem is. Let's go back into the interpret action. We'll move the location of this single quote in here. Hey, that's not right. And then run it again. Come on. All right. Oh, wrong tab. Let's go back here and do this again. Hey, they're wandering again. So we have basic scripting now where we can write the essential logic, or at least the flow of the logic expressions. But now we need to start implementing some more interesting predicates. So things like being able to walk towards a given item, which that's going to require us to do some basic pathfinding. I don't know if I really want to go all the way to A star. Seems overkill. Maybe it's necessary. I don't know. If I go all the way to A star, then it might waste some time. I could do something really dumb where basically they try to move in the direction. But like, let's say there's an item right here. I don't know if you can see where my cursor is. If there's an item right here next to this wall and the character is on the inside and they're trying to just do a naive directional movement, they're either going to try to go right or down to get to that item. They're going to get stuck in this corner. So something a little bit more like A star would be nice. So let's see, A star algorithm. I haven't written this in a while. It may not be that bad. I don't know. It's recursive, isn't it? No. Simple pathfinding algorithm. Trev says, Dijkstra's and then convert to A star. Never. I mean, Dijkstra, I guess, could work. Dijkstra's algorithm, A star algorithm, breadth first search, cycle detection. That's not exactly what I need. Shortest path between 2 points in a graph by evaluating each node in the graph and calculating the distance from the starting node to each node in the graph. Let's see. I see. For each node in the graph, set the node's distance to infinity. Set the node's parent to none. Seems a little bit inefficient. It's like shotgunning. I could be wrong about that. Yeah, A star is way better, I think. Because if you have a straight line, see it, Alejandro. If you have a straight line to the object, it finds it a lot faster because it's trying to just go like the straightest path toward it, and then it will kind of move around it basically. So yeah, that illustration is really nice for kind of showing what the algorithm is. I like that. Okay, let's move a little bit further, let's say. Chris says, I thought A star is just Dijkstra's with heuristics. It's pretty simple to do Dijkstra's and convert it to A star. Probably wrong. Well, I'm sure you're right. I mean, it does look kind of similar based on the two illustrations we just saw. We don't really need the heuristic because there's not really, like, A star normally is concerned with like the cost of going from one tile to another. In our case, it's really, well, it's kind of a binary, like either you can go there or not. But once doors get into the mix, it might be a little bit different. So I'm not sure. Let me get rid of some of this printing because it's probably wasting a lot of cycles. Takes forever. Let me look at what I had in the notes. So there's actions or predicates like find item. So yeah, we could do that. What else do we have? Has item. Yellow key, find open door. Hero is close. Open a door. Yeah, opening a door would be cool. I guess, so let's think about that for a moment. If they're trying to go from one place to another, should they just automatically open a door? We haven't implemented doors yet. I don't think it would be necessarily that hard. In the process of an A star algorithm, I think if you determine that the shortest path, like if there's a room that's sort of in the middle of the map and it has a door, like doors you can go through or you could go around it, A star might decide that the shortest path is not through the door, I guess. But yeah, it could go through the door, and if the direction has a door, they could open the door, but maybe they'll just do it automatically because writing the logic for that, like, I don't really know how I'd do it in the simple language. Just use Manhattan distance, Dave says. A star Manhattan distance. Yeah, with A star. Who knows what they're saying in here? It's been a long time since I wrote A star. Okay. So anyway, back to what we're looking at. So we have treasure visible. I think that's basically the same thing as find item. So I'm trying to think of, like, what is the right way to express these things. So there's a few things we want to do. Walk to item. You need to brush up on those leak code problems before you go to a big tech interview. I hope I will never have to go to a big tech interview again in my life. We'll see about that. Walk to item. Walk to desired item. Pick up item. Are those two separate actions, or are they the same thing? You're we want to go take the item. Take item may imply you have to walk to the item. Let's see, treasure visible, find item. Find item, that's fine, I guess. And has item, find open door. Unlock door. It'd be cool if they could lock doors also. Like, you need to go find the yellow key to lock the yellow door so that the guy doesn't go through it. Flee. I mean, you could flee. You could also fight. I mean, what else would they need to do in the game? It feels like this is not really much, you know? But that's okay, because what you're doing is giving instructions. Like, each of the characters needs to have its own job, and this logic is meant to give them jobs. Instead of clicking buttons to assign jobs, you just write code. We could go further and eventually have it so that you can write more like scheme code. Hey, Glenn. As the week goes on, let's say. Okay, so we got about an hour and a half trying to decide what is the most interesting thing to do. I mean, having an item on the screen, have the monster be able to walk toward it, I think would be pretty interesting. So that does require possibly implementing A star or Dijkstra. Let's just go with Dijkstra. Ouch. Shortest path in a 2D array using Dijkstra's algorithm. Someone is doing their homework on Stack Overflow. Yeah, you know, I don't think I can write classes and schemes, so I can't copy and paste this code, can I? Yeah, that seems pretty simple. Let's just go back to the pseudocode. Mark all nodes as unvisited. I would say, all right. Here's what I want to do. I want to stop everybody from walking to start with. In wander, or maybe what I can do is just make this wander do nothing. So just for testing purposes, we're going to make it so that nobody wanders anymore. Do I need to do anything else? Okay. Because I want them to be still so that I can implement the stuff. Met Some Dog says, I implemented Dijkstra in CL yesterday for 2D array. That's cool. I'll do it too. We just need something simple to get it done. A star would be cool. Maybe we can do it a little bit later. Like Trev says, it's just extra logic plugged into the same algorithm. All right, so I'm going to jump back here, reload, and they should be sitting still. That's good. Logic. Let me comment out this logic right here too, because I don't want to be seeing that every time. No. Okay. All right, so recompile, reload. Now, first of all, there's two components to this. And there's some things we haven't implemented yet. So first of all is define find item. we may need to be passing the whole game. Well, we don't want to pass the whole game object with this. And maybe just the level object. Okay, so entity level. Not entity. Item type, let's say. So find item, item type, and then level. So basically we need to return the map position if such an item exists. Otherwise return false. And if we find such an item, then we need to be able to walk toward it. So I guess the question is, how can we efficiently move toward the item without having to search the whole path? I think that's kind of the problem here. Do you want to like actually have to run the entire algorithm every single tick for every entity that needs to find an item or need to walk toward an item? I guess it's fine. I mean, maybe it's not that inefficient after all. Okay, so define, let's see. If I can store the current path they're moving toward, it might be helpful, but I don't know that this is what I want to do. Let's just be inefficient to start with. It's better to be inefficient and get work done. So find path towards position. Target us. And every frame, the situation of the world may change anyway, so you may have to redo the path. So that does make sense. If somebody closes the door, it might cut your path off and you can't move. And also, if you think about it, if you find an item, should find item return the path and then you have to walk to the path? Because finding an item might imply that, like, if you're prevented from walking through a door to get to where an item is, it shouldn't try to walk to the item. It should do the next thing on the list of tasks. So I think that's going to be important. Like, we'll proceed with that logic. All right, so let's go back to the Dijkstra's algorithm. Mark all nodes as unvisited. Do I need to mark anything, or do I need to just initialize a vector or an empty list? Assign to every node a distance from the start value. For the starting node is 0, and for all other nodes it's infinity, since initially no path is known to these nodes. During the execution of the algorithm, distance of the node n is the length of the shortest path discovered so far between the starting node and n. So you're basically going in reverse from the target. This is what it says here. From a start node lower left to a target node upper right, green, in a robot motion planning problem. Oh, okay. For the starting node is 0. For all other nodes, it's infinity. So, gotcha. Pure Manhattan distance. Is it mentioned here in this page? Wikipedia. Wiki. Simple English. 2 points. The Manhattan distance between the 2 points is x1, x2, y1, y2. Distance can be imagined as a length needed to move between 2 points in a grid where you can only move up, down, left, or right. Yeah, yeah. Well, you can't even do, in this game, I haven't, I don't think I'm going to enable diagonal moves anyway, so we'll have to do that. I see what you're saying. So basically, you're just going to move in one direction in a straight line until you get to the next possible direction. That's fine too. It feels like, I don't know if you ever played, what's it called? RimWorld. I sort of visualize how the characters in that game move. It feels like Manhattan Distance. I have this open somewhere else, don't I? No. Before I even start trying to do this, I probably should have items in the game, shouldn't I? So we have entity, item.scm. So define module, game item. We use it as the heuristic in A-star? Yeah, I think so. Make item. I don't know if there needs to be anything special here. Type, tile ID, position X, position Y. This is something that will require some extra work in tile ed though, probably. So item, and then item, or sorry, type, item type. Tile ID, item, tile ID, position X, item, position X, position Y, item, position Y. Okay, and don't think we really need anything special here. I mean, the thing we could do is just make it so that you don't need to know what the tile ID is. So define make item, type, position X, position Y. However, it might need to be the reverse. Chickadee has a generic A-star procedure is bring your own graph. That's interesting. Hey, Scott. Yeah, I might not be in America. Who knows? Wow, that's a pretty concise algorithm, Dave. Requires a heap, and it's your heap type. Make heap, and you have a sorting function already built in. I guess I should bring this up on the other screen. So D Thompson Chickadee get. Get. And this is in Chickadee data. Pathfinding. And there's also heap that this uses. Yeah, so there's like a lot of the code is the heap implementation, it seems. Yeah, yeah. Well, at least seeing this is kind of useful. Okay. What was I looking at right before that? Oh, I was writing the item type. Heap should be portable to Hoot. Use the vector under the hood. Yeah, if I get desperate enough, I'll copy it. But I think it's only fair if I try to do it myself. Okay, so make item. what I was saying, just sort in priority order. You could do linear scan instead. Yeah, I might actually do that. Basically, what I was thinking is not even use a vector. Just use, like, I'm just going to const a list of pairs or something and just search through it. But or just make a vector that's the size of the map and store the information that way. Could be fine. I don't know. For item. So if I were to place items in the map, which, oh, actually, I'm not placing items in the map. They're going to be randomly generated also. So let's forget about that. That's not the way to do this. The way to do this is to use types. All right. We'll just make it real simple to start with. Define make item type, position X, position Y. We're going to use make item type, and we're going to use a case for type just to map things. So here we're going to say yellow key. Do we have a yellow key in the tile map? I'm pretty sure we do. There it is, yellow key. There's yellow, blue, and red. We can just have 3 of those. That's fine. 571. 571. Same for blue key. Probably 572. 572, 573. Okay. I don't know that we'll have doors with different colors, but let's just start with that. Also, we can have gems of some sort. You know, I think type might need to be sort of hierarchical. Thanks, Dave. Yeah, I think there's some cool future possibilities. This is super dumb compared to what we have in mind, but you know. But I'll catch you later, man. Trev says, one thing I missed was Surfy 9 records as a default constructor with default fields or something. I feel like maybe there's a better record implementation that is going to be added to Guile and to Hoot. The one from Geeks is quite nice. I really like Geeks record implementation. Feels a lot more friendly than the default scheme one. All right, where are we on time? Okay, we've got about an hour. So for make item, I think I want to change this, but does case work? Maybe I need to use match instead. So match, I'll need to import, let's see, use module, boot match. Match type, so let's change how we do this. We're gonna say key yellow instead. Just to have a way to have some characteristics without it being too complex. And then also we can have like gems of different colors, let's say. What do we have here? Yellow gem, blue gem, red gem. That's good enough. That's perfectly fine. So the yellow gem is, what is it, 522? Okay. 522. Gem blue is, come on, 523. Gem red is 524. All right, that probably should have been another function, but why not just do it here? Position X, position Y. And now when you want to make get the voodoo skull in there, where is that? These down here. There's like a dinosaur skull and a human skull. What's that, like instant death? Maybe later, maybe later. We need some of these flasks though, because we want the goblins to want to get drunk. So they have to see that in their path and head that direction instead. At some point we have to give them a mind of their own, and they may decide not to actually follow your instructions. Goblins love Red Bull. Okay, so it's gonna be Red Bull then. It's gonna be super This is a family-friendly game. We're not going to have alcohol. We're just going to have potions, which are equivalent to Red Bull. So if the goblins want to get tachycardia, they can just go grab one of those instead. All right, so make item is all good here, I think. Then in game.scm, how are we going to do this? We need a way to store let's see, game. We're not passing game around. We don't want to pass game around. What I'm seeing is that for entity logic to be applied, we need to have a way to pass in the state of the game world without passing game in, because there will be circular dependencies between these record types, and I don't like that. So we need to probably stash this stuff in level. I've changed the way that level works now, where are we? Level. Now this is basically a constructor function for a given level. Where is it? Make level now returns a lambda, a thunk, effectively, that you call to get a new instance of the level. So it is conceivable that we could store the actual entity list here instead, and not store it in the game. So the level data would be passed around to the different logic functions, so that you could look at the information for the entities or any items in the world. It's not perfect, but that might be the way to do it for now. So we have make level with height tile data. Where's tile data coming from? I think that's coming from the level file. So if we look at level 1, then we have the tile data basically being a list of all the numbers. And that initial information has the positions of all the... Oh, no, it doesn't have any positions of entities or items. It's just the structure of the level. So who would be responsible then for constructing the entities and the items? I suppose that would be game, because game is going to initialize everything. And level itself would not need to know about entities or items. It would just be a container for them. So then let's just do that. So we're already passing the level around to everything, so that should be good enough. So we have level items, level entities. We also need to include an items here. And make level kind of feels a little inaccurate at this point. It's almost like a define level, even though that's also a little bit inaccurate, but it's probably a bit more accurate. But we'll leave that as it is. And we do want to have the ability to set the list of entities or... Oh. And the list of items. Set level items, because we will need to change them over time. We're going to need to export these as well. All right, so spawns, level entities, set level entities. Wow. Typing fail. And also level items, set level items. And now in game.scm, we will take out game entities. We have level. And game entities. Oh, we need to store the game. Oh, we already have that. Okay. So then game entities. Anywhere we call game entities, it needs to be level entities or game level of game. And game entities, current game. That's also this one here. I might need to have a helper for this, but let's just get on with it. Level entities. This is going great, as you can tell. Right here. Okay. I think I may have missed some parens in here too. Level entities. I think I forgot to close that out. Level entities. That one's good. That one is okay. Yeah. All right. So now we've switched it a little bit. What we need to do is also add items. So when we make a game, the level function, we need to also create a list of items. What did we do here? This feels a little bit inefficient, or let's say inelegant for now. So we've created a level instance. We need to create the number of monsters that we've chosen. Maybe we can do this instead. Define generate entities monster count. Let's just move this up a little bit. We could do this without a loop too. Yeah, how about that? Let's do that without a loop. We can just call it recursively, call it stuff recursively. So if monster count, and we need to go all the way. Wait, hold on. Yeah, that's fine. Okay. All the way here, I believe. Seems right. Okay. What other information do we need in this? I think I need to close some things out there. So if greater than 0 monster count, we're going to recursively call generate entities. Make entity generate name. Editor container. Ooh. Random item, guy, demon, entities. We need the hero as well. What about a quantum twist? Well, what would that be? Make game level, const of make entity, doom guy. Cool. All right, that's fine. So we can just store our entities here. Let's just say generate monsters. Also, we do not need a loop anymore. Generate monsters, we can just pick the random and range here because that was a kind of a diversion. Okay, so we got that now. Let's get rid of this external loop. In fact, we can just bind this entities here. We don't need level to generate entities, which is good. We can be done with that. Let's kill these lines. Drop these down. Oh. Okay, so we're gonna make the game. We have our entities list. The thing that I lost was the letrec here, which creates an instance of the editor. Monster could sometimes go through walls less than 1% of the time. Maybe. I mean, as we get further along in the development, there's plenty of room to add new stuff. I mean, I think we're making pretty good progress this week. It's only Tuesday, and we've got the basics of, you know, sort of the game framework worked out. So maybe we'll be able to get to some fun stuff toward the end of the week. So I set up this letrec here. So if monster count is greater than 0, otherwise, let's just return. What was I doing? Let's get the compile time up to 10 seconds. Yeah, that's what we're going to end up doing. Okay. To make this truly recursive in a tail recursive way, which maybe we don't care too much about it, we would actually have to say entities here. I don't like it. And let's not call it entities either. Generate monsters. This is how it would have to be. Not the cleanest scheme function in the world, but it will get the job done. So generate monsters. Okay. So now we have a properly tail recursive function. And the reason why, well, is that true? Yes, because we're pushing the constant forward through the function calls. And eventually we would just return monsters as the final thing. So yeah, we're pushing the result forward and returning just a simple result at the end. So that does make it a tail recursive function. I'm pretty sure const will make things, yeah, we're calling generate monsters here in the branch of an if directly. So that doesn't manipulate the result, it just returns it directly. So it's tail recursive, or tail call optimized. All right, so now we have entities. We can change that to, well, let's leave it entities, it's fine. Generate monsters, random in range. Cool, ooh, what did I do? I did that. All right, there we go. That's good now. Make sure that the first entities script gets loaded. Entity script car entities. I also had the, what was it? The editor thing. What's that about? Editor, make editor, container, map, entity name, entities. If I do a let star here, that should be good enough for that. We don't need to let rec anymore. Okay, that's good, that's good. Let's get rid of let rec. We're gonna bind editor here after we do that. Yes, these are the handler functions. Set editor content, bind entity, blah, blah, blah. Good. Okay, make editor, editor. Now we're back to the let binding, I think. Yeah, all right, good. Set editor, content editor, entity script, car entities, make game level. I think we're getting a lot cleaner now. So we got entities. We need to set them in the level. So now we don't use this in make game. Set level entities. If I can type correctly again. Level. Here we go. And that will take care of that. Now make game level editor. I guess that's the only things now that are still relevant. So make game level entities editor. That's not right. That needs to go away. Okay. Now we will have to double check that this still works after we created it. We also want to create level items. So we will just get a little placeholder here. Set level items, level, just empty list. We will generate those two. Let's recompile just to see what happens. Unexpected syntax inform. Line 20? No, can't be. Check parens. That's fine still. Where did I do it wrong? Usually when you see something like that, it's a let binding that got screwed up. Doesn't actually tell us where it happened, does it? Oh, you know what? I forgot to go to the make file and add item here. I don't think that matters actually right now, but let's just make sure we get everything cleaned up. Super helpful. Can you tell me where the... Okay. These 3 slashes. Come on now. I want... Does it need 4 slashes? I literally want open, close, paren. This should be obvious, shouldn't it? Not working though. No, it's like doing something completely different. I don't even see the result that it thinks it found. Yeah, that's great. Totally what I was looking for. Okay, so how about this? Let's look at our git status and see what things have been added. Item.scm, did I do anything stupid here? I mean, it's always possible. The match should be okay. This file seems more or less fine. Ah, you know what? I realize generate monster. Ooh, where was that? Game.scm. Generate monsters. We are calling it here. Where did we call it? There it is. Got to give it an empty list to start with. That's probably not the problem. That will be a problem. Hey, Elijah. Emacs should already be escaping them. Yeah, it doesn't seem to work. I don't know. Is it because there's not enough? Maybe it wants 3 characters to start the search. Is that what's happening? Is if you just do plain old that, it's not enough? Ah, that's what it is. That can't be the problem. That's the problem. Right there. Okay. Thanks, Elijah. You at least cued my brain well enough to get me to realize the problem. 2 characters is not enough to activate the search. All right. Unbound top level game.scm 88 level. Okay, level. Now, why is level relevant here? Level spawn for type. Cool. we do need the level because we need to find spawn locations. Level, monster count, monsters, fine. And then here in generate monsters, we got to pass through the level. Also in level, I think we need to expand our find spawn. Where is it? Spawn? Oh, is that in game? Find spawn. Where the hell is that at? Find spawn. What am I doing wrong? Level spawn. Level spawn. There it is. Or type. Currently, I'm not even looking at type, so that's fine. I need to start thinking about item spawning as well. So gotta make sure that everything works for both. And maybe in different ways, but for now, it's just gonna be anywhere. We'll scope in the logic later. Level spawn for type. Level is here. Now we pass level through. We should be good. Unbound top level editor. That's in, let's see, game somewhere. Editor, editor, make editor. Set. Oh, right. This is why I did let rec. Because 102. Yeah, exactly. I need to, editor has to be self-referential. That's okay. We'll just do a little let rec inside to, what's the best way to do this? Okay, yeah. I mean, let rec is probably fine to do even right here. I don't see any reason why not. Okay, let's not be an idiot. Come on. That should do it. Wrong number of arguments to generate monsters. Ah, yes, okay. Level. Just kill it and restart it. Come on. Come on. All right. Wrong number of arguments. We have absolutely no information about what is being called. Record with no printer. So, wrong number of arguments. It sounds like the instantiation of a record type is not getting the things that it needs. Make game level editor. That one seems fine. I bet it's make level. So let's go back to level. Make level. Width, height, tiles, spawns. Yep, that's the one right here. Psychic debugging for the win. Who needs a type checker whenever you have your brain to help you? Okay, we're back to where we were. It's good. Game loads. Everything is initialized the way I expect it to be, so that's good. Now, we can try to generate some items. So back here, just as we had generate monsters, we can have a generate items. In fact, I think we can generalize this generation scheme to generate anything. But maybe let's just not bother with that for now. In fact, how about this? Let's be fast. Monsters, items. All right. And then monster here also needs to be item. All right, so random item. We're gonna want to pick from a number of key yellow, key red, key blue. We'll have to be a little bit smarter about this in the near future because we need to make sure that we have the same number of locked doors as we have keys of a certain type. So we'll probably have to work backward. We'll have to look at the location where doors can be, generate the possible number of doors, and whichever one, however many there are that are locked up to a given number, there needs to be keys generated for those. So that will be for later. For now, we will say gem yellow, gem blue, gem red. So these are the types of items that we can pick from. We also don't need to generate a name here. We need to use make item to do this. So random item and level spawn for a type item. That's cool. Monster count needs to be item count. So let's do that too. Monster item. And then we can do the same thing for items here. Generate items. Level random in range. Well, let's just do the same thing for the monster spawn limits. We can do an item spawn limits as well. So maybe 1 to 8. How about that? And we'll change monster to item here. Not what I wanted to do. Okay. So monster spawn limits. Limiters. Okay. And we also need to have an empty list right there to initiate it. So now we should be able to stuff those items into the level. And then in the, we don't have to update them, but we do need to draw them. So we're gonna have to copy the draw entities code right here. Let's draw the entities after drawing the items. So entity item. All right. And then right here, level items. We can just pull this up right here. I think that's fine. Same for here. All right. I don't think it's frozen anymore, is it? YouTube's bugging. Sometimes my webcam does freeze because of the poor drivers for the capture card that I use. Okay, so we have items. It may draw the items, draw item, context item, tile sheet. I need to go back to entity, steal the draw entity. Yeah, okay, steal the draw entity, go to item.sem, paste it down here. Let's just change entity to item, boom. And in here we will need our level and tile sheet modules, I believe. Maybe also util, but we'll figure it out. Okay, so tile size, tile sheet, tile size, tile sheet. Wow. For everything, we're just like grabbing that, huh? Draw image, context. All that looks okay. So in theory, we should be able to recompile and see items on the screen. If it works. Draw image. Okay, we need to export draw image, of course. No, we do need to draw item, but we also need to pull in use module DOM canvas to help with that problem. And item X. Okay, so let's change this. So post X will be X. Or in fact, oh, yeah, there we go, there we go. Let's call that map X and map Y. Sorry, what was that? Okay, let's go. Generate items. So generate item. Okay, wrong arguments to make item. Random item, that would give us the item type. Level spawn for type. Okay, so what did I do for entity? Make entity. Position. All right, that's fine. We'll do the same thing for this then. We will say car for position and Twitter for position. And then we'll take a position here. Waiting. Okay, let's check it out. All right, there's a bunch of items. I would say that's far too many, and probably we should not generate 3 blue keys. So we need some limitations. Let's like maybe reduce the number of possible items. Item spawn limits. You want to say like 1 to 3? I don't know. It feels like too many, having up to 8. Maybe 4 is better, but we do need to limit the number of keys. That's fine though. Like, we'll fix that another time. So now that we've got items in the world, it is possible that we could start writing a pathfinding algorithm to target a particular type of item. Find entity. Game name. I think that this also should now be level. We can move this to be reused. Okay, so that gives us 1 key. All right, we got a gem, a couple keys that are in that locked room. How's anybody gonna get in there? Who knows? We can take find entity and move it into entity. Let's see, we're gonna export find entity. Is anything in here? Entities level, null entities, cool. I think all that is pretty generic and doesn't require anything else. We're gonna do the same thing for find item, I think. All this stuff is kind of like, this is a little bit different. The criteria is different. We need to find an item of a particular type. Equal name. Yeah, we do need equal. Type. Let's see, item type. And that equal should do a deep equality for the items of the list, so it should be fine. Wow says, do you have interactive changes or are you having to compile every time? I am having to compile every time. That's a temporary limitation of Guile Hoot because it does not have a scheme interpreter written yet. You can only compile the code at the moment. But that's something that will come later. Okay, so we've got our find item. We did not actually export that yet. Of course, we're not using it, so that's not a big deal. Also, we'll check this. There we go. So level entities, failed type check. Where was that being called? Level entities, level. Oh, find entity. That's it. Find entity. There it is, right there. So, game level current game. That's what's needed. All right. Yep, that's only a temporary problem. Part of the goal of this jam entry is to sort of explore the beginnings of possibly having an interactive development experience for a Hoot application in the browser. Damn, did it again. All right, level entities type check failed. I'm passing the wrong thing. Oh. Find entity. Find entity. Level entities. I'm pulling in level here. Game level. Ooh. Actually, do I even need to do that? Because I have access to the level instance itself. Game level. Yeah. Oh, I missed one of the instances here. Okay, that's fine. Game level current game. There we go. Oh, what did I just do? Okay. That should do it. End of input. I knew I did something wrong. I think that's it, right? Needs to be a green paren at the end. Okay. Wrong number of arguments to set into the script. Whoops. What'd I do? Ah. Yep. A little bit of a mistake there. That's probably why things did not line up correctly. And set entity script. That looks good. Some necessary slight refactoring today just to get the game in the right position to move forward. All right, so we're going to select the entity, and it seems that it works now. So we can load up the script for any given entity the same way. We are seeing items and everything being generated correctly. Great. Now, do we have time to write a pathfinding algorithm? I don't know. Guess we'll find out. Choose a starting node. This is going to be in entity.scm. We had started writing a, what was it? Where was that? Find path, target position. Let's say target X, target Y. Also, we need start X, start Y. So start X, start Y. We also need the level. So we have access to the walkability of tiles. There's also a tile walkable function that I created, which is for tile ID. Okay, so I can get the tile ID at the location. Sounds good. So mark all nodes as unvisited, assign to every node a distance from start value. For the starting node, it's 0, and for all other nodes, it's infinity. For the current node, consider all of its unvisited neighbors and update their distances through the current node. All of its unvisited neighbors. How do we say whether they're visited or not? Update their distances through the current node. Compare the newly calculated distance. to the one currently assigned to the neighbor. Dislike W says, I enjoy seeing how smoothly your Emacs runs. I don't know, is it smooth? Shortest path can be extracted from the set of visited nodes by starting from the target node and picking its neighbor with the shortest distance, going back to start on an optimal path. Starting from the target node and picking its neighbor with the shortest distance, going back to start on an optimal path. If the target node distance is infinity, no path exists. Well, we can say that maybe false is infinity. Actually, Scheme has infinity value. Pretty sure there is one. Yeah, plus inf. So we can do that in Scheme. I guess that you can do that in Hoot. We'll find out. Let me do this real quick. Let's just pop this over to the front, move to start, and then I'll have this be right here so it's easy to flip back and forth to the notes. And we do this in 30 minutes. I guess we'll find out whether I will pass a big tech company interview by whether I can write this algorithm. All right, so mark all nodes as unvisited. What we could do is have a let for level, can we get the, let's see, level I think has a width and a height. Loop says, have you considered something like Sideberry? Yes, I have considered it. I just haven't used it yet. All right, so let's see. Level width? Yes, level width. Okay. We're gonna multiply level width level by okay. Let's think about it first. Level height level. We'll probably make some bindings for these if we need to. Okay. When I call make vector, I think they're all false to start with. All the positions. Now, they're all unvisited. Assign to every node a distance from start value. We might have to do some funky stuff here. Let's try this instead. Positions. Because I want to do some nested functions. Just use some defines here. So define, what would that be? X, Y, distance. Assign to every node a distance from start value. For the starting node, it's 0, and for all other nodes, it's infinity. Okay, so we got set distance. What we'll say is vector set. Is that right? Yeah. Positions. Plus X times Y level width level. That's the index we're shooting for. And then the distance value. That's a little helper that will help us to set the distance for a given position. We're going to start by setting the position of the start position. So set distance start X, start Y, 0. For the starting node is 0, and for all other nodes is infinity, since initially no path is known to these nodes. I think what I'll do is, if we try to get the distance for a node, vector ref. We'll do a little bit of an or here. Or vector ref positions. Probably should abstract this position calculation. That's fine. That's not supposed to be of. So we're getting vector ref. Yeah, okay. So with the or, we're going to say positive infinity. I guess all distances should be floating point numbers as well. Trev says, for distances you can use in a SOAK list. Maybe. I could do that. Maybe I'll find out that this is not the optimal way to do the algorithm anyway. All right, so consider all of its unvisited neighbors and update their distances through the current node. Compare the newly calculated distance to the one currently assigned to the neighbor and assign it the smaller one. Okay, so we need to start looping through the positions. So loop position X, start X, position Y, start Y. This doesn't feel right, but let's just go with it for the moment. Compare the newly calculated distance to be the one currently assigned to the neighbor. We're done considering all the unvisited neighbors of the current node. Mark the current node as visited. It's easier just to have a get neighbors that takes a node. Yeah, that's not a bad idea, just to loop through those. I mean, we could do that. Let me think about this for a second. So for the current node, we start with the start position. Set the current node to be the starting node. For the current node, consider all of its unvisited neighbors and update their distances through the current node. If A is marked with a distance of 6 and the edge connecting it with its neighbor B has length 2, 6 plus 2 is 8. If B was previously marked with a distance greater than 8, update it to 8. Fine. Otherwise, keep its current distance. Path to B through A is not the shortest. Visiting all the unvisited neighbors of the current node. Mark the current node as visited. For the current node, consider all of its unvisited neighbors. Are we thinking of its unvisited neighbors in terms of whether it's been visited from a particular starting position or visited at all? A visited node will never be checked again. Thanks to Stixter. Not sure exactly how to pronounce that. All right. I think this actually won't be that hard. It seems pretty uniform. So consider all of its unvisited neighbors. So each of the entries in the vector need to not only be the distance, I believe they also need to be marked or not marked, but I guess purely having a value, doesn't it imply that they've been visited? I think that's kind of the case, right? So maybe I don't need this part. So for a given position, I just need a way to generate the neighbors, like Trev said. Oh, there's a little bit of a missing close paren there. Define get neighbors, x, y. All right. So this is going to generate a list, let's say. Let loop possible neighbors. I mean, we sort of did something like this with that wander procedure already, right here, that directions thing. What I want to do is loop over the possible moves. Welcome to the fantastic world of topology. Yeah. Let's just call it deers. Whatever. Okay, so we got deers. We've also got the neighbors list that we're going to generate as a result of this. All right. And as we step through, we're going to check to see if the number one, the position is valid, and number two, whether the node has already been visited to generate a list of neighbors to go through. Is that right? Yeah, okay. So is the position valid within bounds? Has the position been visited? All right, so we need to first decide new x is plus x r, yeah, car deers. And I need to make sure I'm not doing plus x incorrectly here. Okay. We have the new x and the new y. If greater than or equal to new x 0, it's gonna have to be a series of ands. Okay, so that would give us the first check, and the other would be vector ref. We'll say not vector ref. Same equation, new x, that's gonna be a plus. New y times level width level. So if it's both of those, also that needs to be inside the other. Right here. Then we will call, okay, I think I can flip this logic. Check this out. We're gonna loop, we're gonna say cdr deers, and we're gonna say, we're gonna use the if here to drive the decision about whether we're gonna const a const of new x, new y onto the list of neighbors, or we're just gonna straight up return the existing neighbors list. That's okay. That might work. So just to double check my code here, we start at x and y. We generate a list of possible moves from the current position. We have an empty neighbors list. We calculate the new position based on the first entry of deers Then we immediately call loop one thing I did not do is if null deers, then we return neighbors. My brain is reaching its limit right now, so typing is not cooperating. All right, so if the deers list is empty now, like if we loop through it to the point where it's empty, go ahead and just return the current value of neighbors. Otherwise, we will loop through the next step. We'll do our checks. Level width, level, all that looks right and not found already. Then we're going to const the position onto neighbors list. Otherwise, we return the current neighbors. Cool. So get neighbors. Now, we will need to recursively loop over the neighbors of a given point. So first of all, we set distance here, and then we need to start looking for like process neighbors, get neighbors. Okay, let's say process neighbors, start X, start Y. And this process neighbors function would be called recursively, I believe, because we're effectively walking over all of the neighbors. Consider all of its unvisited neighbors, update their distances through the current node, compare the newly calculated distance to the one currently assigned to the neighbor, and assign it a smaller one. We are looking at, is that right? Is what I'm doing right? I think this visited check might not be done here. Because oh, it is. Consider all its unvisited neighbors. Update their distances to the current node. Man, I'm losing it. When we're done considering all the unvisited neighbors of the current node, mark the current node as visited and remove it from the unvisited set. Ooh, how do I do that? No, that's right. When we're done considering all of the unvisited neighbors of the current node, mark the current node as visited. So it has to be done after. In general, you want to have a set of unvisited nodes and a distance map where you have each coordinate distance it is from the start. So maybe I need to separate those two things. I mean, I can encode that. But I guess unvisited probably means mark the current node as visited, remove it from the unvisited set. Visited node will never be checked again. Do I need to be like keep looping while there are more unvisited nodes in the set? First step is to remove it from the set of unvisited. Okay. So it's like you need a list of unvisited nodes that you will pull from when you want to visit the next node effectively. But you have to start from the start point. So when you loop over the neighbors, do you add each of the neighbors to the unvisited list? And then loop again, and you basically go through the take the next item off the unvisited list and keep looping? Is that probably the way you do that? Because you don't want to like pre-generate the unvisited list for the entire map, because it's not going to be in the right order for the traversal. Mark all nodes as unvisited. Create a set of all the unvisited nodes. So it's telling me I need to create a set of all the unvisited nodes. Do I have a set or anything like that in Hoot, I wonder? Probably not. I think there's a hash set. Let me see. What was that I was doing? Error earlier. Hash. Yes, add the origin to the unvisited set, pop it out, find its neighbors, add those to the unvisited set, and continue. Those are not included. Hash. Is there a hash in the path? No. I think there's a hash table. Whoa. Backend. Lib. Hoot equal hash table ref. Hoot hash tables. Sweet. What's the equality? Okay. Make EQ hash table, make EQV hash table. Not so easy. Oh, maybe make hash table is equal? Equal hash, okay. Hash table hash function. Hash function. Hash function. Equal hash. Make unimplemented error. Okay. Yeah. Maybe. This feels icky. And also, well, maybe it doesn't matter. I'm overthinking it, as always. I'm wondering if we can do anything. Sorry, if we can get anything done in the remaining time. Okay, so I obviously need to have an unvisited somewhere. So if I define an unvisited list, they tell me mark all nodes as unvisited. Assign to every node a distance from the start value. Yeah, I can just start pushing things onto the unvisited list, I guess. I mean, you're gonna have to roll over the whole list anyway, aren't you? Like, you'll have to go over the entire map. According to this graphic, you're gonna look at the whole map anyway, so it doesn't really matter what order you go in, so long as you just do it. Do I have procedures for removing things from lists? Let's see, remove. Wow, remove lib. No. Boot reflect, Hoot web server, backend. Oh, yeah, let's look at this. Remove. That's for hash tables. Okay. Starting with the empty set and adding the start point. Once you get the start point's neighbor to add that to the set, continue on. Not sure if... Yeah. No, that's what I was thinking. That would work fine. It's just the removing from the visited list, but maybe that's fine. Maybe that's fine. I mean, we're going to remove whenever we take one off to deal with it. You can add, yeah, okay. So let's just do it this way. Not vector ref. No, let's not do it that way. We will say member const new x new y unvisited, because that will tell us if ooh, wait, need to make sure member, what? Come on now, I know that's in there. Lib boot soak. All right, there you go. No, where is it? Entity. This is probably already pulled in. Use module hoot soak. All right. So not member const new x new y. Oh yeah, I forgot to look at what the VL. V must be the value. Okay. That's the if. What is this? Define, find path, level. It's an orange. Gotta delete that. Hickory using goops? No, not using goops. Goops is not in hoot. Not yet, anyway. All right, I don't have much time left here. Let me just see what I can do really quickly. So if not member const new x new y and unvisited, then we're going to const it onto the neighbors list. I should also const it onto the unvisited. Whoa, I think I screwed that up too. There we go. Dirty, dirty mutable state code. Unvisited. Can I hold on to that const? Like let's star here. I feel like I'm doing that a few times. Const new position unvisited. And then this will be new position neighbors. Okay. So now we got an unvisited list. Excuse me. And loop could start with the position of const start x start y. Also, I think I need to double check that that position is not already in unvisited. I think that probably will matter. Okay, so now we got position, and unvisited is sort of implicitly part of the loop. So we just start with this. Then when we loop again, we're going to use the car of unvisited. Yep. So that will let us loop through the unvisited list. If pair. Okay. Or let's say when. we need to do something first. So here we would say, can I do that? And then we do something at the end here. So false, yeah. Find the shortest distance from the target position. Okay. Shortest distance neighbor from the target position. I think this is mostly implemented. It's hard to verify this right now, though. Like, sure, you could just wait for the entity to move towards this particular object, but yeah, I think that, I guess we could write out a path. Once the loop exits, the shortest path can be extracted from the set of visited nodes by starting from the target node and picking its neighbor with the shortest distance going back to start on an optimal path. So effectively, you're just starting from the target position, and then you're looking up the shortest path of all of the possible neighbors from that location. And then you just go, you keep going that direction until you end up at the start position. And then that's the path. You would just have a list const from that position. Okay, that seems reasonable. I feel like I'm missing. Yeah, something here is bad. I think I did not finish. What happened? If null, there's maybe 10 more minutes and then I'll have to jump off. All right, so what I've done so far is I've got the start position. This is kind of stupid what I just did, but I guess we have to do this the way that this is implemented. So we get the neighbors for the car and cutter values of the position, which is the X and Y coordinates of the position. Get neighbors, that will return a list of possible neighbors to navigate from that or position to calculate their distances. So for those neighbors, we might need to do a nested loop because we need to calculate things for each of those. So maybe this also needs to be an inner loop. And for each neighbor, I mean, do we do anything with the neighbors? We're just sort of like mutating some internal state in this procedure. So I don't think we really need to, I think we could do a when here. So when neighbors is a pair, we can proceed. We can calculate the distance. So for the current node, consider all of its unvisited neighbors, update their distances through the current node. Compare the newly calculated distance to the one currently assigned to the neighbor. The distance of a node X is the length of the shortest path discovered so far between the starting node and N. And that's, let's see. For example, if current node is A is marked with a distance of 6, and the edge connecting it with its neighbor B has length 2, then distance to B through A if B was previously marked with a distance greater than 8, then update it to 8. So, do I just use like a distance value of 1? I mean, sorry, increase the distance from the previous node. Not exactly sure, unless I'm supposed to calculate using Manhattan, the distance value between the two. Maybe that's what I'm supposed to do. So we had that algorithm for that, which is just a simple absolute value of x1 minus x2 plus y1 minus y2. Maybe that's what I need to do. Yeah, I think that makes sense actually. So define calculate distance from x1, y1, x2, y2. That's going to be x1 minus x2, right? And that's the absolute value. I think that works. We're also going to add this together. Is that it? Okay. And we want to set the distance at the location. Set distance. That's actually a good place to check. So okay, we'll move this up because it's used first. Not really necessary, but just to make it more readable. We have the current distance. If current current is less than distance. Wait a second, hold on. Or not current. Or distance is less than current. We can say this is a win even. Then vector set. Okay, so I think that helps us there. Thanks, STX sticks. Yeah, I know I need to be using the smart parens bindings. All right, so set distance, current is get distance xy. If current is not set, which if it's never been set before, it won't be set. Or if the current distance is less than the new distance is less than the current, then we set with the new distance value. And we have calculate distance. So now we should be able to say on the set distance is XY distance. Okay. Yikes. I need to have the position values handy. NX is car neighborhoods. You see how well my brain is doing right now. NY. Gross. Okay. I think that's okay. I need to also do an inner loop at the end of this. So inner loop. Consider neighbors. Phew. Okay. I think I've got too many closing parens somehow. So we're starting with a position of start X, start Y. Eventually we will look at the next unvisited location. We're going to loop to the next unvisited location. We're going to have an inner loop that looks at the neighbors of the current position. We're going to get the list of neighbors, which will take into account the visited or unvisited state. So we'll get a list of neighbors. Whenever we still have neighbors to process, we will get their X and Y position, and we'll set the distance of that neighbor relative to the current position using Manhattan distance. I'm going to start tweaking this again. And then we're going to loop on the remaining neighbors. And that loop does not have to return anything. We're just going to step through to the next part, which is looking at the rest of the unvisited items. Now, when we call get neighbors, we're automatically adding each neighbor position to the unvisited list. So I wonder, consider all of its unvisited neighbors. Consider all of its unvisited neighbors. I don't know, actually. Consider all of its unvisited neighbors. You would have to have the, I think you would have to have the unvisited neighbor list fully populated, because you need to remove it from the list when it's been visited. Does this illustration start from... Okay, it starts from the start position. Maybe it is adding those to the unvisited neighbors list. You can see it has kind of these circles. Open nodes represent the tentative set, aka the set of unvisited nodes. Okay, so it does actually do that. I wish I could restart it. There we go. Okay, so it starts from the beginning. All right, I think we're gonna have to test this tomorrow. I don't have time to finish it today. We've got it mostly written, so I'm happy about that, but obviously we don't have time to test it. I have to go and take care of some family business right now, so I'm gonna go ahead and just commit this code. Actually, if I commit it, it's gonna break everything. Or maybe it won't. As long as the code compiles. How about we just make sure the code compiles? If it compiles, then it will push the next update to the duplicate imports. Let me get rid of that Assoc here, because probably I don't need that. If it compiles, then the new build will get kicked out from the line 151 from the CI, and it will go live on the website. All right, 151 neighbors, get neighbors, unbound top level. How is that? 152 actually. Pair neighbors. Did I close this out? What? Ah, damn. Typos galore. If the code compiles and the game runs, I will commit it and we'll be done. Okay, let's try it out. It looks fine. I'll turn the wandering logic back on too, just so that anybody who loads the game up will see that happening. Go to swim? Nah, not going to swim today. Gotta take my kid to basketball practice. That's okay. It's just another place where I can sit with my laptop and look at my computer. All right, here we go. Wandering is back on. So I think we did pretty good. We got items in the game now. We got the basic logic scripts. Like, this actually does something now. If I were to take the wander out for old Wasex here, whatever their name is, and hit run, one of these will stop moving. I think it must have been this one right here. But if I go put wander back on again and make sure that I close it correctly and hit run, then they will start moving again. So the scripting does work. It actually does something, which is cool. But we still have a lot of work left to do to make the pathfinding work towards items. But once pathfinding towards items work, then we can do things like, you know, picking up items, moving toward doors, and other things like that. So I think that is a really good progress for the day. You just need to finish up that pathfinding algorithm tomorrow. And then we can just focus on polishing up game logic and the whole game loop. We need to be able to make it possible to win the game, I guess. But I think that by the end of the week, we should be able to do that. So cool, good progress so far. Thank you all for being here today. Really appreciate your time and attention. Let me commit this stuff real quick, just so that you have access to it if you want to take a look. Let's do that real quick. I'll just commit all the files. I don't care. I know what I added. Let's see. Add items. Well, basic scripting. Items and untested pathfinding algo. So once I push this, the CI will kick off a build, and you'll be able to go to the fluxharmonic.itch.io/lambda-dungeon website and click restore game here, or click play game, I think, and it will pop open an overlay that will enable you to play the game. If you click that right now, it's going to give you the old version, but pretty soon the new stuff will be in, so you can check it out there. Cool. All right, well, I'll be back around the same time tomorrow, so you can continue to watch me fumble through and figure out how to do all this stuff. And until next time, happy hacking. We'll see ya.